Hello, everyone, and welcome to another episode of Computer Science and Artificial Intelligence. In this episode, we will cover multi-regression. Specifically, we're going to program a multi-regression. So in our previous video, we already went ahead and derived all the equations necessary to program a multi-regression. So if you haven't, I'll leave the link in the description so that you can go ahead and watch that video. It's actually not too long, and once you watch that video, you can come back to this one and then you'll know what is going on. So again, we'll be coding a multi-regression. For this, we'll be using Python. And let's revisit the problem statement that we had set in our previous video. So we have collected 15 months of data for a startup company that we are thinking of investing on. We have collected 3 variables in those 15 months. 2 that are affecting the market value of the company, and those variables are the reputation and the innovation levels, and the market value itself. So additionally, we have made predictions or projections on what the reputation and innovation will be on the 27th month, meaning 1 year after we invest, if we were to invest in the 15th month, right? So based on what the company is going to market in the next year. Now, the problem is that we don't know exactly how the reputation and innovation of the company are affecting its market value. So as computer scientists, we want to program or code a multi-regression to see how much money we will make if we invest or if we buy 35% of the company on the 15th month and sell after 1 year, and our projections obviously become true. So let's revisit the data that we had before. So we have this data set. It includes our innovation level and our reputation level. The month number is just the month in which we collected these variables. And of course, we also collected the market value. So these are our projections for the 27th month. And our projections say that we will have an innovation level of 3, and we'll have a reputation level of 0.35 for that particular company, right? So this is again how the graph looks. I already went ahead and explained why this graph looks like this in my previous video. So if you haven't, again, go and watch it before you continue here. So these are our equations that we derived from our previous video or in our previous video. Again, I will express this in terms of the dot product because it's a lot easier to program this way, as you will see as we move on with our code. And these are also the equations that we will use to update the nth weight, and this is to update the bias again, or the b value. Again, this eta here is the learning rate. In our linear regression video we use mu, but it's okay. We'll actually use this one because it's more common in artificial intelligence and neural networks. Great, so let's go ahead and move to our code. So as you can see, I have already prepared the project. I have coded some of the basic things that we will need. I have not touched the multi-regression model. This is what we will code in the video, but let me just go ahead and explain what is going on. So in the first line here, I'm importing the multi-regression that we will code, and I'm just using the custom name MR just for short. And I'm also importing NumPy because I'm going to use NumPy since we're going to be dealing with a lot of matrices and arrays. And remember that we will be using the dot product, and actually NumPy has a really cool feature that allows us to do the dot product between 2 matrices. So our y value and x value, as you can see here, they're separated. In our linear regression, we had 1 input variable and 1 output variable, so we could easily use the same array and just have them set up as pairs. But here, since we have multiple x values, in fact, an undefined number of n values of x values, we will have them separated into 2 arrays. So this first array contains all the inputs or all the x values, and this y contains the output. For a multi-regression, the output is always 1, right? So in our particular case, I've already gone ahead and put in all the input variables or input, and I have already put in all the outputs. So these are the reputation and innovation pairs, which are our inputs, and These are our market values. So let me just clarify. We don't have to put the month as an input because the month doesn't really define the price. We just use the month to graph the data set so that we could see how it's moving in terms of time. But the real thing, the real variables that are affecting the market value are the reputation and innovation levels. So those are the only ones that we have to take into consideration when it comes to this particular model of multi-regression. So here we're just creating the multi-regression model. Here we're using the fit function. So fit and train are the same functions. I just prefer to use fit in this case. And as our inputs to this function, I'm just giving it the x and the y. Finally, we're printing something here that answers the question. There's a typo here. Let's just say reputation. So after our projected innovation and reputation levels for this company, our model says that our profits will be, and then we get the profits from this function here, RETINV, or return on investment. So this function is not implemented yet, and I can see that we will need a few inputs. So for example, I can input the share, the x, and I will go ahead and explain what this will be. And let's say initial market value. And I think that's pretty much it. So let's see. Let's define first what our initial investment is, right? So init IV, which is initial investment, is just how much of the company we bought. So this is what the share represents. What share of the company we have. This is a number between 0 and 1. So the share times the initial market value. The initial market value here is defined as the market value at the point that you invested. So the X represents one of these pairs with pretty much with the reputation and innovation levels. And this can be passed as the input to our prediction function or to our predict function from the multi-regression model. So let's just say future MV, which is future market value, is MR model that predict, and it will take X. So we'll simply return the future market value minus the initial market value, and this should give us what our profits will be, right? So whatever we get at the end minus whatever investment we made in the beginning, this is our total profits. Great, so this is pretty much implemented, right? So let me go ahead now and move on to the good part, which is the multi-regression. Great, so in the initializer, we have to initialize the bias. We'll just do it how we did it in the linear regression. So random times 2 minus 1, so that it gives us a random number between -1 and 1. And the weights. So let me just call this weights. Now, we cannot just have one weight. Remember that we must have multiple weights. And we want to code this multi-regression to work for any data set that fits in a multi-regression model. In this particular case, we have two input variables. So we will have two cases or two weights. But if our data set had more than two x's, then we would need as many weights as we have x's. So here we can just ask for the number of inputs. So let me just call this inputs, and this will tell us how many weights are needed for this particular model, right? So here NumPy actually has a really cool function, random sample actually, that allows you to initialize randomly a sample of n values or n items. Great. So this is all for our initializer. So let's now go with the predict, because the predict is actually pretty simple. So the predict will take an x value, and this x value is an array of for one input. So one input may consist of many inputs. And when I say one input, I mean one sample really. It should be one sample. So one sample may contain many inputs. So you know that this X here is an array. And if we go back to our formula, we know that we can get the prediction. This is the derivative of the cost, right? But the prediction is just a dot product between all the weights and all the inputs for 1 point plus b. So this is just a prediction. So let's just take it from there. So let's just return np dot dot. This is the numpy for dot product of the weights. The weights is a matrix here, an array or a matrix, right? And whatever x we have plus b, that will give us the prediction. That's pretty much it. That's all we need to do. Easy, right? And it's not just p, it would be self.b. All right, great. So the cost is equally simple. But remember, this is the prediction for 1 point. So we don't need to iterate over anything. But for this one, this is cumulative, right? So we need to get the cost for all the points. So we have to iterate for I in, okay, so range x dot shape, it should be in 0. All right, so for those of you that don't know what the shape function is, let me just give you an example real quick. So when you have an array n times m, where n is the number of rows and m is the number of columns, then the shape, so the shape will be n comma m. This is what the shape will be, n comma m. And remember that in our particular case, we have an input, and I don't know how many inputs it has, but that's the first number that will be the number of rows. So if we look at our data set, this is the number of rows. We have 15 rows. From 1 through 15, we have 15 rows. We have only 2 columns, 15 rows. So we want to iterate over each sample, right? So this will iterate over each sample of x. Each sample of x may contain more than one x value. But that's not what's important, because we know that we can just say total plus equals np dot between the weights and xi. This is the dot product of all the weights and one sample of x. One sample of x. Because remember, this is propagating. The weights don't change for a sample. The weights are the same for every sample. What changes are the inputs, because we're propagating the error here. So this is the cost, right? Or the cost. I'm saying error and cost are used interchangeably. That doesn't really matter. So plus b minus y in I also. Let me go over the y in I. So remember that our formula says that we have to use the ith y. Why? Because this is the inputs for the ith cost, right? So these are the inputs for the ith cost, but there is just one y value, right? It's just one y value. And then all of this we square it. So one y value per sample. So now all we have to do is square this. So squared. And this is pretty much what the cost will become. Of course, we have to return the total. Now let's do the same thing for the derivative of the cost with respect to b, which should be pretty similar to this. I'm just going to copy this. And this will just be, instead of squared, it's just 2 times that. 2 times that. And also very similar to the derivative of the cost with respect to the nth weight. Again, it's not going to be squared, it's going to be 2 times xi in n. Let me explain what's going on here. So let's go back to our formula of the derivative of the cost with respect to the nth weight. Okay, so I decided to leave it in this form. So we have with the derivative of the cost with respect to the nth weight. And this is what it says. We have x, the nth x for the ith sample. And this is pretty much what we have before. So this represents a dot product, right? Weight 0 times x0 in ith for the ith sample. This is just, this part we can ignore. This is just a dot product. This is the b, and this is the ith y. What we care about is this, because we're taking the derivative of the nth weight, so all the other thing will become constants, so it will be 0, and then this w, the derivative of the nth weight with respect to the nth weight is just 1, and then 1 times x, the ith x for the nth x for the ith sample is just the nth x for the ith sample. If we get back here, that's precisely what we're saying. We're talking about the ith sample, the nth x. This will return the row of inputs, and this will return the particular input that we're talking about. Great, so now that this is all computed to, let me just return the total. Return total here, and also here, which I forgot to do again. Return total. And now the fit function. Fit is the same thing as training, remember. So this is actually the easiest function of them all. I think they're all pretty easy, by the way. So let's see. How many times do we have to iterate? We have to iterate as many times as we are requested. So for range in n iterations. Okay, so we have to update y and b, and we have to update each weight. So let's see. Let's update b first. So b minus equal, this part we already know. This is eta times the derivative of the cost with respect to the bias for the x and y, right? That's the data set. Now we have to iterate because we don't know how many n's, how many weights we have. We have to iterate. So we have to iterate over the shape, right? So we have for n in range of self.weights.shape in 0, right? So this will pretty much return again the length of the matrix, or the number of rows in the matrix. Remember, this is just a one-dimensional array, so everything can be counted as a number of rows. And what do we want to do? We want to say, well, self.weights in n, meaning the nth weight minus equal eta, which is our learning rate, times the derivative of the cost with respect to the nth weight. So we have to pass n, x, and y. So this will return the derivative of the cost with respect to the nth weight. Remember that with the derivative of the cost with the nth weight, the only thing that changes is this. And obviously this is the only thing that the n is affecting, which value of x will multiply it by. So that's pretty much it for the training. All we have to do is now get some inputs, so some output going here, so that we know what we're doing. So let's say print, and let me just say, for the 0th iteration, or before iteration, we have weights equal, let me just print the weights here, then b, or the bias, equals self.b, and then let's also print the cost. So cost equals self.cost for that sample, right? X, comma, y. Oops, I think I have this here. Great. Okay, so now I can have a print counter here so that we can print it 10 times, or a tenth of the number of iterations, meaning 10 times in total. So let's just say for if number of iterations divided by 10 equals the print counter. So let's just say, let's print this. Well, we'll print I, right? And then let's just say, let's reset the print counter, and then let's include the print counter plus equals 1. And I think that's pretty much it. I hope there are no mistakes. We'll just try it out and see if everything works fine. If something here is not working fine, then we'll go ahead and fix it. Right, so we already have the inputs, the output for the training part, and it seems like we're missing a parameter here. And of course, because we are requesting the number of inputs. Oh, and here I see that I have a mistake. It's future market value minus initial investment. Okay, so it's not just future market value, it's share times future market value, because remember, we don't own the whole company, we own a portion of it. Okay, so now that we got that out of the way, let's just go ahead. The inputs will be x.shape 1. So this will give us a number of inputs. Why? Because remember, the shape returns, if we have an n by m matrix, the shape will be a tuple n comma m. In our case, the number of inputs, meaning n, or the number of rows, is 15, but we don't want to create 15 weights. We only want to create as many weights as we have inputs individually. So we have only 2 inputs. So we want to do shape in 1 so that we get the m value. Great. And here, of course, we have to have our parameters. So we have that we're going to invest 35, we're going to buy 35, and then this is according to our projections. Our projections are going to be 3 and 0.35. And the initial market value, I'm just going to take it directly from here. This is the initial market value. And then we have our multi-regression model. Let's see if this works, guys. I hope it does. If not, we'll fix it. So we have a gigantic cost, and it seems like it's decreasing, so something is working. Our cost is decreasing. At the end, it was 1. So let me just clarify something, guys, by the way. So you see that in our previous linear regression model, this number was very, very low, and it also started very, very low. So here it started at a very high number. We are dealing with very high output values. And remember that when we initialize this, we're initializing this as very low numbers, between -1 and 1. This is why this error is so big here, because we are pretty much trying to use, so we're pretty much comparing really small values to really large values, and this is why the error is so big. Something else that you might have noticed, by default, this fit function takes a learning rate of 0.001 and a number of iterations of 100,000, which is what we use for our linear regression. When you have, as the dimensionality of your inputs increase, you will need more iterations to have a better performing model. So let's just increase the number of iterations to 1 million. 1, 2, 3, 1, 2, 3, and see if this cost increases even more. By the way, you can see that the weights are very high and the bias is very, very low in this case. I guess the bias is meant to be low. So let's go ahead and do that again. So it seems like now it's taking a lot longer, obviously, because we have many more iterations. We have 10 times more iterations, and this is after 100,000 iterations. The cost is lower than it was before. Great, so that means that we started at a better place than we did before. And you see now the cost is very, very, very low. Let's see if it can get lower than that even. So it's getting lower, but it doesn't seem like it's getting lower by too much. So in fact, it was lower at this point. But let's see. We'll just let it finish. I'm probably going to fast forward through this. Great, so after training this, our cost didn't change that much. So in the past 800,000 iterations, so from 200,000 to 1 million, which is what we use, our cost didn't decrease that much. So that tells us that probably we should just do 200,000 iterations. So something else that you might want to experiment with is changing the learning rate, because the learning rate actually affects by how much the derivative of the cost influences the actual updating of the weights and biases. So you might want to try a higher ETA or ADA. So let's just say that 0.01 instead of 0.001 and see if that works. By the way, let's see. It seems like we're making 500,000 in total. If we buy, let's say, what if we buy instead of 35? Let's say we buy 50% of the company. This is why it's good to have everything generalized, because I would have to change something here, whereas here I just have to change a parameter, by the way. So let's go ahead and run that away for 200,000 iterations. And guys, it seems like by increasing this ADA, I was able to get to the cost much lower, a lot faster. So only after 20,000 iterations, the cost was very, very low, which is considerably better. So remember that it's good to play around with these things, because now it requires probably even less. Maybe I can do it with 50,000 iterations and I could get the cost as low as this is. So yeah, just play around with it. Now it says that we will make 724,000. So let me just say something before. So I know that some of you may be familiar with the concept of overfitting. For purposes of this multi-regression, we're not considering overfitting at all, because we are using the same sample to train this multi-regression over and over again. As we move on and we actually explore neural networks and feed-forward neural networks, we will see that this is not a very good technique, because you may get to the point where you're overfitting the model, meaning that the model is very good at predicting whatever you use as the inputs, but when it comes to real world data, it's not very accurate. So we will tackle overfitting when we move on to neural networks. So for now, we'll just leave all these as it is, and of course, now I realized that I said, okay, now it's 50% of the company, so that's why there is so much of a difference here. So if I just like playing around with this. If we invest at 80%, now it's much faster because I decreased the number of iterations. We will make 1.1 million. So guys, this is actually very good if you guys like investing in things. You might want to try something like this. Of course, it's not that easy to have a reputation and innovation level like this in a way that you can code a multi-regression, but as we move on and we go into more detailed things such as neural networks, you will see that there are actually very good ways in which you can use that for financial purposes, even though it can be used for a much broader field than just finances. So as we move on, we will see that neural networks can actually predict, even though we don't have such high details, because I will confess something, these numbers were engineered so that we can get very precise, a model that works pretty much. If we have these numbers slightly off, maybe this will not even work, because our cost will just keep or will not decrease that much. See, here the cost is very high, so we know that this is not very accurate. So yeah, so when we move on to neural networks, we'll break down this into more pieces, and we'll see how neural networks are so great, so great when it comes to a lot of data. And we'll talk about many of the advantages and disadvantages of neural networks. So guys, this is all for this episode. So once again, I want to leave you with this thought, and I want to just clarify something. When I say ask questions, I don't necessarily mean ask questions to other people. Maybe you want to ask questions to yourself, like, why is this working this way? Why is this working that way? Because when you ask yourselves questions, then you actually want to find answers. And if you find answers, if you look for answers, you learn a lot more. This is why I say be curious, ask questions, and then if you find something out, then try it out and see if it works. Um, I just want to say, if you have any questions about this, if you have any comments or any thoughts, please leave a comment. Also, if you like this video, please like this video and subscribe if you want to see more videos of this channel in the future.